So last time we did equations. Remember, higher potential gains electrons, lower potential loses electrons, and we figured out how to predict what a reaction is going to be. So in any reaction, you're going to look for the highest and the lowest. As long as just saying a question that you had Fe2 plus Cl minus 1, H2O2. So I wrote down all reactions involving Fe2 plus Cl minus 1, H2O2. And we figured out that this was the highest potential, it gained electrons, and this was the lowest potential, it lost electrons. And you had to select the highest and lowest according to your reactants. The one that's going to lose electrons, you need to have that as your reactant. And the one that's going to gain electrons, you need to have that as your reactant. So 1.77, highest potential would gain electrons. The lowest, you had other substances having lower potential, but you didn't have those substances. So which is why we cut out a few equations. तो चलो ठीक है, यहाँ से start करते हैं. We started doing chain reactions, so I'm going to just focus on those chain reactions where you would have. उसके बाद खत्म कर देंगे, ठीक है, the equation part. So you had equations. एक second, meeting controls hide कर लें. So you had reactions where the reaction would kind of go on. After the first reaction, you'll have another reaction. So right now, initially, you have these two as your reactants. You've got vanadium and you've got excess I2. So you're going to look at the data booklet. एक second. And you're going to look for vanadium and I2. So for I2, you have this just one equation, this one. There's only one equation for I2, okay? So I'm just going to copy that. I'm just going to copy that one equation. And you've got just one equation for vanadium as well. कहाँ पे? अच्छा, there's only one equation where vanadium is involved, which is ये पहली वाली. minus 1.2 volts. ठीक है, so these two equations, and we can figure out a reaction based on these two. So again, the higher one gains electrons, the lower one, this is the higher one, and that's my lower one. Okay, so you got your reaction, right? You have to, the electrons are also balanced, so you just add up the reactants. The first reactant is I2. In the second one, the reactant is vanadium. And my product is, in the first one, it's 2I minus 1. And in the second one, it's vanadium 2 plus, right? The E naught cell is also positive, so you can calculate the E naught cell as well. So there's nothing wrong with this, and we got our first reaction, okay? So you got this reaction that's going on. Now, once the first reaction has happened, what is left? What's the leftover stuff in your beaker? ठीक है, तो यहाँ पे लिख देते हैं leftover. So now I've got V2 plus that's formed, and I've got 2I minus 1. ठीक है, those are my products, and I have excess iodine, so that means there is still some iodine left. ठीक है, was that clear?
Yep, it's clear.
So अब ये करना है कि what I'm going to do is I'm going to just try and figure out whether there's going to be a reaction between them. So we've got the iodine equation again. So let's just copy that. ठीक है, ये इधर आ गई iodine वाली. I've got I minus 1, that's the same equation. Vanadium 2 plus, I got this one reaction for vanadium 2 plus, that's the same one. So let's keep it over here as well. And vanadium 2 plus, there's if you look at the data booklet, there's going to be another equation for vanadium 2 plus, and that's this one where it's in equilibrium with vanadium 3 plus, so it could possibly form vanadium 3 plus as well. That's minus 0.26 volts. So there's another possibility with vanadium 2 plus now. Okay, it can turn into vanadium 3 plus. अब इसका देख लेते हैं कि what's going to happen in this case. So we've got 1 second. टिश्यू 1 सेकंड बोलता. अच्छा, इसका reaction, the one that we have in front of us, it's the higher potential is still iodine, so that wins. It gains electrons, right? So ठीक है, there's nothing wrong with it. I still have iodine in my excess iodine, right? It was added in excess. So what else? Who's going to lose electrons? So minus 1.2, that's the lowest potential. Vanadium is the one that's going to lose electrons. We don't have any vanadium anymore. वो पहले reaction में ना all the vanadium got converted into vanadium 2 plus. Now you don't have vanadium, so I'm going to leave that. I'm going to cut it out. ठीक है, this one. Who's my lowest potential? It's minus 0.26. So vanadium 2 plus is the one that loses electrons. We do have vanadium 2 plus as my reactant. I would have to multiply this by 2 as well because the electrons need to be balanced. So the reaction now is Ki iodine, and the other reactant is 2 vanadium 2 plus. And my product is in the first one it's 2i minus 1, and the second one it's 2v3 plus. Okay, so I got my. So now I've gotten my second reaction. So ठीक है, ये clear है?
Yep, it's clear.
अच्छा, अब ये again you're going to have some leftover, right? So what's the leftover stuff after this reaction? So the leftover stuff is you again have I minus 1 as your product. You got V3 plus, and you still have iodine, the excess iodine. ठीक है, so ये products बने and you still got excess iodine. So I'm going to look for their equations again. ठीक है, will there be another reaction? ठीक है, so I'm going to pick the same equation for iodine and I minus 1. ठीक है, it's the same one. और कौन सा चाहिए? I need vanadium 3 plus equation. So there's one, this. So I got vanadium 3 plus. There's another equation for vanadium 3 plus, and it's getting further oxidized to this thing. VO with a charge of 2 plus, right? That's 0.34. So again, the highest potential at the moment is in Cup Carlo. Highest potential at the moment is the first one. That's fine. ठीक है, iodine gains electrons. Who loses electrons? Minus 0.26 is the lowest potential. Vanadium 2 plus should lose electrons, but there's no vanadium 2 plus anymore. ठीक है, वो पहले part में ना vanadium 2 plus got converted into vanadium 3 plus. You don't have any vanadium 2 plus, so it's not going to lose electrons. ठीक है, so remove that equation. So the lower potential is vanadium 3 plus that's losing electrons, ठीक है? And you got this reaction now, ठीक है? That's your, and this has to be multiplied by 2 as well, so that the electrons gain and lost are equal. So you found your higher and your lower potential, so reactants, add up the reactants, so it's I2 plus यहाँ पे क्या, it's 2V3 plus I think 2H2O, or product क्या 2VO2 plus and 4H plus 1. Yep. ठीक है, so you've got a third reaction. Okay, so you got your third reaction. So basically, what is happening is Okay, it's iodine reacting everywhere. Iodine oxidized vanadium to vanadium 2 plus, then vanadium 2 plus got turned into vanadium 3 plus, then that vanadium 3 plus further turned into vanadium. I think over here it's plus 4, right? So it kept getting oxidized. I said, will there be another? So basically, I'll just focus on the trend. So iodine is oxidizing vanadium 3 plus to vanadium 4 plus. So I'll just quickly figure out whether there's going to be further oxidation or not. ठीक है? तो यहाँ पे मैं उसको इकट्ठा करके देख लेता हूँ कि where's I mean, iodine is not in this page. I'm just going to write iodine over here. So this was what was going on. Iodine kept getting reduced. Vanadium being the lower potential lost electron, right? Minus 1.2. Then vanadium 2 plus being the lower potential lost electron again compared to iodine. Okay? So iodine oxidized vanadium 2 plus further because it was the lower potential. Then the vanadium 3 plus formed was also further oxidized to VO2 plus because it was still the lower potential compared to iodine. Iodine kept getting reduced and vanadium kept getting oxidized. Okay? After vanadium 4 plus, it's not going to get further oxidized. Why? Because but ये वाला काम नहीं होगा. VO2 plus turning into VO2 with a charge. I mean, this is, I think, vanadium over here is plus 5. So vanadium will not turn into plus 5 because it's no longer the lower potential. The lower potential loses electrons, the higher one gains electrons. So ये 1 volt पे जाके it's going to stop. So after this, there's not going to be any further oxidation. ठीक है? Is this clear, Pradha?
Yep.
तो बस इस point से आगे ना, there's not going to be any further oxidation. So we're going to just, I mean, instead of doing it again, we'll just stop at this point. Okay? So it's basically 3 reactions happening, and what you can now do is you can go and add up all of those 3 reactions, and you'll get your overall reaction. So that's number 1. Okay? That's number 2, और फिर यहाँ पे there's number. So there's number 3. So I'm just going to add all 3 reactions. तो तीनों को add करो तो it's going to be iodine, iodine, iodine. So I think there's so why is there three iodines, right? Things that appear on both sides will get cancelled out. इसको देख लो. Is it getting ये मसला है. Remember vanadium 2 plus in the first reaction is now being used up in the second reaction, right? So यहाँ पे the equation had 2 vanadium 2 plus. So I'm going to multiply the first equation by 2. तो ये वाला part जो है ना, this will become 4i minus 1. अब ठीक है. अच्छा, तो ये clear है? Did you get this? Okay, why I multiplied it by 2? Because there's 2 vanadium 2 plus over here. So if 2 vanadium 2 plus is getting formed, then in the second equation, 2 vanadium 2 plus are turning into 2 vanadium 3 plus, right? So it's a sequential reaction, so the numbers have to be balanced. Okay? Were they clear? Is this part clear?
Yep, it's clear.
So just start adding them up. It's going to be 4 iodine on the left side. I said things on both sides will get cancelled out. So this gets cancelled out. Vanadium 3 plus will get cancelled out. So you're left with 2V and bus 2V plus 2H2O. I said the products on the right side. You got 4i minus 1, 2, and 2. अच्छा नहीं, you got अच्छा I minus 1. Sorry, यहाँ पे नीचे ना there's I minus 1 as well. I think there's going to be 2i minus 1. I forgot that. अच्छा, there's 2i minus 1. The 2i 4 8i minus 1. Or right side पे क्या है? That's 2 VO 2 plus or plus 4H plus 1. But yeah, so I figured out. I figured out the overall reaction. Okay. So is this clear? This reaction?
Yep, it's clear.
But see, basically, you wouldn't really get you'll most likely get a very simple reaction. Okay, when we do past paper questions, most of the questions are going to be very straightforward and very, 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 very simple. There's actually another one which is very common. That's I mean, basically chain reactions. You're going to deal with chain reactions specifically when you have elements that have multiple oxidation states. जैसे यहाँ पे vanadium, ठीक है? I mean, for example, if you're dealing with zinc, you're not going to have a chain reaction because zinc will either turn into Zn2 plus, and that will be it. There's not going to be any further change in oxidation states. So you just have to really think about redox reactions, which are chain reactions, when substances have multiple oxidation states. So one example is Mn. वो मैं यहीं पे कर लेता हूँ, ठीक है? So let's say I'm reacting. I'm doing this. I have a reaction of Fe2 plus with MnO4 minus 1, and that MnO4 minus 1 is acidified. So what's going to happen is that the Fe2 plus. So I'll do all the working over here. Okay, so I got Fe2 plus in this reaction, and I got Fe2 plus in this reaction as well. And I've got acidified MnO4 in two of the reactions. One is over here, MnO4 minus 1. The other one is the next one, which is MnO4 minus 1 as well. Okay, so I got in both of the reactions, I've got MnO4 minus 1. So if I do a reaction, the reaction will be, who's got the highest potential? It's 1.67. That's the highest potential, right? So that's the one that's going to gain electron, right? And that's fine because I have MnO4 minus 1. I have 4H plus 1. So that gains electrons. So that's fine. And who's going to lose electrons? The one that's got the lowest potential. So inmates it's minus 0.44. But I don't have Fe. I don't have Fe, so that can't lose electrons. So the next lowest potential is 0.77. So that means Fe2 plus is the one that's going to get oxidized, right? So you're going to end up with a reaction. ठीक है, इसको लिख भी लेते हैं कि इसका क्या होगा कि so I'm going to get, I mean, if I write the first reaction, okay, let's do it over here. अच्छा, MnO4 minus 1 acidified. So first reaction was Fe2 plus was getting oxidized. So the first one is, and I think I have to multiply it by 3. ठीक है, वो उधर से copy कर लेते हैं. ठीक है, the electrons have to be balanced. So forget the other reactions. I'm just going to rub them off. This is gone. The bottom one is also gone. So it's just these two reactions. So Fe3 plus has to be multiplied by Fe2 plus has to be multiplied by 3. MnO4 minus 1 plus 4H plus 1. So MnO4 minus 1. And the product is 3 Fe3 plus पता नहीं क्या बन रहा था. It was forming MnO2 and 2H2O. अच्छा, ये पहला reaction हो गया, ठीक है. And so what do you have after the first reaction? You've got Fe2 plus. Then the Fe2 plus is the one that's in excess. So you still have some Fe2 plus left. The MnO4 minus 1 has been turned into MnO2. Plus it's still acidified, okay? The whole solution is acidified. So I'm going to now see that in the first reaction, Mn plus 7 turned into, I mean, यहाँ पे it's Mn plus 7. And now it's turned into Mn plus 4. Now, after the first reaction, I'm going to see if there's going to be a further reaction. And my candidates for the further reaction is that my solution has this thing now, okay? Varda, ये सारा clear अभी तक?
Yep, it's clear.
अच्छा, so I'm going to look for a reaction between them, Fe2 plus MnO2 acidified, right? So let's remove the working for the. अच्छा, इधर भी change कर लेता हूँ. Now there's no more MnO4 minus 1. We're dealing with MnO2 now. अच्छा, so again, I'm going to mark the equations. Fe2 plus, I got two equations, this one and this one. MnO2 acidified, I've got this equation, MnO2, that's called MnO2 acidified. There's no other equation for MnO2 where MnO2 is acid. I mean, I'll mark the other ones as well. Okay, but there's no point. There is no MnO2. Or MnO2 नहीं है. Just these equations. And I'm going to find out what the reaction is going to be. So who's the highest potential right now? It's 1.67. MnO4 is the one that's going to gain electrons, but we don't have MnO4 minus 1. So I'm just going to cut this out. That's not going to work for us. 1.23 is going to work for us, TK, because my reactants, they do have MnO2 and they have H plus 1. So that's the one that's going to gain electrons. And who's going to lose electrons? The lowest potential, minus 0.44. Fe is going to lose. I don't have Fe, so I'm going to cut that out. The lowest concept, that's 0.77. That's going to work. I do have Fe2 plus, TK. So that's my reaction now, TK. You clear?
Yep.
Or baki mein, I'm just going to rub them off, TK. So it's between these two. And we're going to see what will happen. So I think this has to be multiplied by 2 because electrons need to be balanced. So it's going to be 2 Fe2 plus and then MnO2 4H plus 1. So 2 Fe2 plus. That's a plus MnO2 plus 4H plus 1. And the product is going to be 2 Fe3 plus Mn, that's 2 plus and 2H2O. Was here. So that's my second reaction. Okay, so that's my second reaction. Now, after the second reaction, I've got, again, the same thing. I've got excess Fe2 plus. The Mn has now gotten further reduced to Mn2 plus, acidified, okay? So Mn plus 7 से start होता good turn to plus 4 turn into plus 2, right? So will there be a further reaction? No, there's not going to be a further reaction because if Fe is going to get oxidized, it has to be the lower potential, right? Problem with Mn2 plus is that Mn2 plus will not get reduced further. क्योंकि उसकी जो मतलब यही हो रहा था ना, MnO4 turned into MnO2, MnO2 further got reduced to Mn2 plus. Mn2 plus will not get further reduced because its potential is very, very low. So gain कौन करता है? The higher potential gains electrons. It's not going to be the higher potential, so you won't really get a reaction. ठीक है? Is this clear?
Yep, it's clear.
तो इधर से start हुआ था कि Mn got reduced first time, second time, but Mn2 plus will not get further reduced. Too lower potential, so it's going to stop. So if you make the overall equation in this case, I say if you make the overall equation in this case, it's going to be 5Fe2 plus. Or you cancel out हो जाएंगे. Intermediates will get cancelled out. MnO4 minus 1 plus H plus 1. And the product is 5Fe3 plus Mn2 plus 4H2O. That's it. Okay, so that's your. So that's our reaction. So okay, so ये वाला I'm just going to stop. Okay, we've made too many equations. Most of the equations are going to be very straightforward. Not they're going to be extremely simple and straightforward. Okay. So most of the questions are just going to be about drawing. It's not complicated. I mean, they can ask this, but they're not going to ask that frequently. So moving on. We're going to talk a bit about electrolysis. So electrolysis is the opposite of an electrochemical cell. I say electrochemical cell में क्या होता था? When you had an electrochemical cell, you had what was the basic concept of an electrochemical cell? You had a reduction reaction and you had an oxidation reaction. मतलब एक side पे electrons were gained, the higher potential side, you had a lower potential side where electrons were lost. And because of that, there's going to be a potential difference created. And because of the voltage difference, there's going to be a current produced. Electrons will flow from one side to the other side. Okay, Varda, is this clear?
Yep.
I said now electrolysis. What is electrolysis then? So electrolysis by definition is decomposition of electrolyte by passing current. Of an That's by passing current. So how is electrolysis different from an electrochemical cell? In electrolysis, you already have a battery. Use an external battery. That battery creates a potential difference. And because of that potential difference, current is already produced. Electrons are already moving even before the reaction. And because of the movement of the electrons, what you have is this creates a reaction. You have reduction at one side, that's the cathode side, and oxidation on the other side, that's your anode. ठीक है, तो reduction or oxidation, you have that. So it's just the reverse of electrochemical cell. So I'm going to do a simple electrolysis. पहले तो simple कर लेते हैं. ठीक है, so I've got a beaker with electrodes. So right now it's inert electrodes. ठीक है, तो एक electrode यहाँ पे, एक यहाँ पे. और उनके बीच में ना there's a battery. अच्छा, उनके बीच में there's a battery. And you've got well, hopefully you know this. This is the negative terminal and that's your positive terminal. Electrons are flowing from one end and electrons are coming back from the electrons are already flowing. And remember, it's inert electrodes, platinum electrodes. So electrons are already moving around. So if you have like molten magnesium oxide liquid state, so you got magnesium ions which will be attracted to cathode, and you're going to have oxide ions which will be attracted to the anode. And अच्छा तो cathode वाली side पे कर लेते हैं. Cathode के अंदर at cathode, remember there is no option of oxidation. The only thing that's going to happen is only reduction. अच्छा वो electrons are coming in, so there's only one option, and that is that Mg would gain electrons. That's it. ठीक है, there is no other option. So Mg over here. अच्छा, can only gain electrons, and that's it. ठीक है, और कोई option नहीं है. And you've got the other side, which is your anode side, and ये वाली anode. अच्छा, anode पे क्या होगा? Only oxidation. अच्छा, only oxidation, and your reaction at anode in this case will be the oxide ions would lose electrons. So यहाँ पे क्या हो रहा है? Magnesium would gain electrons, and on the other side you got only one option, which is electrons will be pulled by the battery. So the oxide ions which are diatomic, वो याद रखना कि which elements are diatomic, so there should be two oxide ions. They would end up losing 4 electrons and it's going to become oxygen gas. ठीक है? So that's your reaction. इस साइड पे ये reaction है, ठीक है? So this is basic electrolysis. No option for the substance to I mean, there's only one option, which is cathode pe it's only going to be gain of electrons, only gain of electrons, only reduction. Anode pe it's only going to be oxidation, ठीक है? Is this clear?
Yep, it's clear.
So if you're cathode pair, focus on cathode. If you're going to gain electrons, who gains electrons? The one that's got the higher E naught. Or दूसरी side पे, if you're talking about losing electrons, who loses electrons? The one that's got the lower E naught. That's got the greater tendency. अच्छा, इस वाले example में ना, that's not an issue. You don't really have to focus on higher or lower E naught because there's only one option. मसला आएगा when you have multiple options. For example, if you had magnesium ions and you had H+1 ions and you had some other positive ion like Na+1 or copper+2. If you had multiple ions, फिर figure out करना मसला होगा कि who's going to get reduced, who's going to gain electrons. Who's going to gain electrons? The one that's got the higher E naught. Or यहाँ पे भी if you had multiple ions, like you had oxide, you had chloride, you had fluoride, then who's going to lose electrons? The one that's got the lowest E naught. इस वाले केस में you don't really have to worry about higher E naught or lower E naught, ठीक है? तो concept clear है electrolysis?
Yep, it's clear.
So ठीक है, next class we'll do more complicated questions on this, ठीक है? कल का ना I forgot. I thought we were starting on Thursday this week. Today is Thursday, right? ठीक है.
Yes, that's it today.
So I think I forgot Wednesday. Tomorrow 2 days, ठीक है? It might be the class is on. Might be. I'm pretty sure the internet will be on as well. but maybe because of Muharram, it's maybe if the internet is not working, all the mobiles are off. So don't wait for like wait for 5. I mean, most likely the home internet will be on. Okay, so there's going to be class. Okay, but if I don't reply like 5-10 minutes, then that means all signals are off at my side. Okay.
Okay.
Okay. Take care, Allah Hafiz.
Okay. Thank you, Allah Hafiz.